Good afternoon. I'm Brendan Sullivan, the CTO of RigNet, and I am pleased to be, for my third year in a row, participating in the future of oil and gas. Today, I'd like to talk briefly about an interesting topic on ensuring AI success, but from a little bit different topic. I noticed in the agenda that there's a lot of different topics on machine learning, on digital twins. I want to talk about that topic, but really about other things that make the program successful. And by that, I mostly mean, how do you get the data from your oil and gas site all the way back to your data lake? And how does a robust network play into your total cost of ownership? Before I do that, for those that aren't familiar with RigNet, let me start by just giving you a little background. So RigNet has been around for about 45 years, since the mid-70s. As the name would imply, we got our start as a very specialized telecommunications company providing offshore communications to oil rigs, right? RigNet. And today we probably have about 35% global market share of providing comms. And it's not just in satellite communications, but really in all forms of RF communication, microwave, offshore LTE. That's been our core business and still represents maybe 70% of our business today. But over time, we've diversified. And some of those that are pertinent to this conversation is really, we have a construction company on the right here. You see our system integration. What that basically is a company that's been around for a few decades, where we have designers who for large capital projects, design, assemble, factory acceptance test, communication networks, and it could be upstream, midstream, or downstream. And then added to that, our latest segment of our business has been our apps and IoT division that's been around for more than 5 years here. Today we, on the narrowband side, have the largest machine-to-machine BGAN network in the world. So SCADA networks, we have more than 11,000 sites active. And on top of that sits a whole host of applications that are all optimized for network, but designed to either help you with safety, cybersecurity, or workforce productivity. The centerpiece of that whole thing is our AI platform, which I'll talk about in just a second. But as we assembled our strategy for the last 5 years, we knew that energy, and this is going back to the last downturn in energy in 2015, we knew that digital transformation was the next logical step, because to try to make 40% margin on $40 a barrel of oil, it required significant savings to the operational costs. And that's what digital transformation is all about, is reducing that operational cost. And it could be either ship to shore or productive maintenance or productivity in a number of different ways. And so we started assembling either through acquisition or through organically designing a new set of things to add on top of that network, because we figured, who was in a better position when you're the only way a lot of these sites can communicate? When you control the network stack, who better to optimize that network for different types of digital sensors and cameras and all sorts of things, so that, to do a short-term project, you didn't have to go out and buy more network that can be quite expensive offshore. So who better to optimize that? Who better to secure that? So we knew as you started to punch holes into these HSE systems that weren't networked before, they were pretty much air-gapped, there was significant cyber risk. So we layered on top of that, a division of cybersecurity products. And then on top of that, put machine learning, real-time capabilities, AI analytics, to really create a bundle of accelerations for anybody, wherever they were in the maturity model, that was trying to enable digital transformation on land or offshore, but very specifically to oil and gas. Our AI company, which has been around for about 10 years, is called Intelli, and the platform that runs in the cloud is called Intelli Live. And it works with many of the super majors and state-owned entities around the world, where it is optimizing either for operational productivity or for predictive maintenance. And I'll talk a little bit more there. But really, for the purpose of this discussion, it doesn't matter if it's our AI platform or someone else's. How do you make this all work together? What's your best path to success? So I'm going to use a composite of, because this is about use cases, and I'm going to give you two use cases here. But I'm really going to take a composite of several different projects over the last 12 months and try to explain them at a very high level without destroying your will to live. So I'm not going to get down into data tags. But let me start with just non-productive time. So within our Intelli platform, we have about 40, 45 specific applications that are using real-time stream analytics and machine learning to help optimize whatever that process is, right? It could be hole cleaning, it could be kick detection. There's a whole host of things that happen. And as many of you know, as you're in many different rig states and you're drilling in the upstream process, there's lots of ways to lose efficiency throughout the whole process. And so regardless of what the sub metric is, we roll everything up to one Uber metric, which is really non-productive time. So reducing NPT, even if it's less than 1%, can have significant savings to the overall program. And throughout the process of drilling, whether it's a 90-day or 180-day campaign or longer, there's all sorts of things that can add up to non-productive time. It could be as simple as crew inefficiency from crew A to crew B. It could be more sophisticated things like stuck pipe, drag and hole cleaning problems, etc. Or a breakdown where you're out of operations as the driller for several days. And so the goal of these AI applications is to reduce that. And so, what are the types of savings we can see after running this on fleets on a worldwide basis? So if you take savings, and again, this is a composite of many, the real savings are usually more than this. But what we're starting to see, and I can give you a little bit more breakdown, is that people that are running these applications getting to work on today's censored up rigs can see somewhere between 10 and 20x return on investment for the software package, right? So if you think about the North Sea and you think about, which is pretty harsh conditions, and the day rate of just renting a rig, your operational cost on average, even in a down market, somewhere in the $650,000 a day rate if you're the operator running it. And you take a series of these applications and you lower your non-productive time by about 3%. That's roughly $20,000 a day. And that's done by a combination of using the real-time process analytics to squeeze non-productive time on every single shift. It's about doing preventative maintenance to proactively keep things from breaking down. And in a lot of cases, if you can not have to fly the 25-year expert out to the rig for some kind of 2-week-long project or for oversight, instead park them in a real-time operating center and using RTOC tools and video, let them coach somebody with a lot less experience in real time, and then be working on 4 or 5 different rigs at the same time that are in different rig states, then you can see multiples of this type of savings. But we're seeing on average that once these programs are up and running, per rig, somewhere in the neighborhood of $7 million per year. And on average, we typically start with 10 rigs at a time, sometimes 20. So these are significant yielded savings in non-productive time in this metric. Now, let's talk about another use case here. So FPSO. So you've got some of the largest ships in the world as floating production and storage operations centers. And there's about 197 of them in the world. And these are massive vessels, some of the largest on the planet, and they have significant amounts of revenue generation per day with long-term, long-shift crews on board. So as you can imagine, there are lots of opportunities to squeeze operational savings out of FPSOs. RigNet, there's about 197 of the world if you take the FLNGs. RigNet in the past year has been operating on about 40 of these around the globe. If you add in the work we've been doing in the last 5 years with the SI group, we've probably outfitted another additional 40 of them coming out of the yard. So somewhere in the neighborhood of 40% of all the FPSOs have one of these RigNet services on them. So what does this use case look like? Well, on a drill rig, the higher yield savings, while we do some predictive maintenance stuff for the drilling contractor, it's usually the operator we're working on the productivity of the workforce that yields the biggest savings. But in an FPSO, which is constantly in operations, it really is much more about avoiding downtime or shortening downtime, because on average in FPSO, these massive vessels can be producing 100,000 barrels per day, right? At $40 a barrel, just taking that average, that's $40,000 per day in revenue generated. And so any type of safety issue that requires a shutdown, any type of preventative maintenance, you have delayed revenue and in some cases lost revenue. And so FPSOs are much more hardened as far as resiliency and redundancy. But so taking a more conservative estimate here of only a 1% savings, that's still about $15 million a year we're seeing in these new outfitted FPSOs in operational savings by using AI and machine learning, a combination of industrial IoT and predictive analytics. So pretty significant prize for the amount of spend being thrown at this phase of digital transformation. Now, what I like to talk about as we kick off these digital transformation projects and as I'm working with enterprise architects is to really achieve that ROI. It is not simply about the software, right? There is lots of software out there. There's lots of startup companies that have very interesting technology and good platform technology, but getting it to work offshore is incredibly challenging. Literally getting the network to stay at the right resiliency and the right security level takes a lot of forethought and a lot of planning, and in a lot of cases, specialized networks. And so it is often overlooked inside these programs, spending all their time working in their digital transformation groups about trying to get the software to work. And that's important. And people will tell you also you need to clean up your data. It's been our philosophy all along that just get started. Yes, clean data will help with the predictive accuracy, but you can yield a tremendous amount of savings even with messy, dirty data. And over time, as your data becomes more mapped, more consistent, then the predictive analytics will improve and the savings will improve with it. But don't wait around for 2 years to just clean up the data. Get started. Now, what does trip people up quite a bit is they don't really think about how hard it is, where you've got a software team on one side that is writing code and they're probably testing against something like the Amazon cloud. They're not having to deal with a satellite that takes over a second round trip. They're not dealing with a security team yet that's going to enforce massive protections and a number of firewalls that sit out there to block hackers from hacking back in the other direction. And so when they fire this stuff up the first time offshore, frequently because there's too much latency or there's too much packet loss, they don't yield the right results. I was working about 6 months ago with one of our clients, and we had very sophisticated monitoring where every 4 hours we were measuring the data accuracy that would go from the sensors to shore. And in this case, they were throwing off about 50,000 data tags per second on 20 rigs, so 1 million data points a second. We were only using about 5,000 of that, so let's keep the numbers a little simpler. So 100,000 tags a second. Based on a whole bunch of factors, whether it was pouring rain over the site, whether their data collectors, from their OPC collectors to their communication hub, would get stuck and need to be bounced. We saw days within that month where the data quality from the day before would go down in excess of 80%. So for a period of time, 80% of the value of the data was incorrect. Now, I don't care how good your software is, it is not going to get over an 80% data problem. And so what I like to advise people to do up front is to really pay attention with the type of network you're using, the design of the network, the security layer, map those things all out in parallel to the software being designed, and you will get a much more successful program. Now, how does that work? Well, many people in 2020 are trying to lay out an SD-WAN solution, and that's great, right? That will help your resiliency. That will help how quickly you can get stuff stood up and make changes to it. But that's a very complicated selection process, and installing one of those things can absolutely break all the accelerators and firewalls you set up previously. So sit down early and discuss this, right? There are many pitfalls, and I won't go through this whole chart here, that can really harm your data accuracy, even if you have well-mapped data. Now, the other thing I would say is a lot of times, we see people that are just going with their local provider. They could be offshore, and they could be using Orange or AT&T. And while these are very good network providers, they're not specialized for oil and gas. So go with a provider that has designed their network specifically for energy. And there are a few of us. But as you can see from this picture here, the RigNet network operated in 52 countries. With the exception of Russia and China, everywhere where there's an oil field, there's a pre-built network. And it's not just in C-band, it's in KU, KA, L-band, it's mid-earth, low earth, it's microwave. So make sure you pick the right type of network for how latency sensitive your applications can be. Another thing is in enabling the FPSO use case, starting less than 18 months ago, we started about 5 years ago getting the mid-earth network and working, which is SES's O3b network. And why is this important? Because when you're 86,000 kilometers in outer space and you have to bounce your network off of that, your round trip is 1.5 seconds. And if you're trying to make real-time decisions in order to fix a process or avoid an accident, 1.5 seconds is a lifetime. With a mid-earth network, your latency is only 125 milliseconds, right? You're much closer to the satellites themselves. And so not surprisingly, many of these digital twin solutions have been going with this type of mid-earth solution. And as you can see, we've gone from 20 megabits of low latency traffic worldwide offshore to about 600 megabits. So it's really starting to dominate in the FPSO space. As the low Earth satellite networks become available, options will explode from there. But that's a ways out, right? That's probably 2024, 2025 before those are ready for the high resiliency required for the oil and gas industry. And they'll be really in the consumer space. Many people are also dabbling, whether it's the North Shore or it's land or it's the Gulf of Mexico. Here's our 5G low latency Gulf of Mexico network. That's only 16 milliseconds. And so your applications will really scream over that network. But what most people don't realize is over most LTE networks, there is no quality of service. And so when you don't have quality of service enabled, your machine-to-machine data that is super latency sensitive is going to be a lower priority on that network than even email is going to be. And so you could spend, you could save money and hook this up expecting great results, but unless you have a specialized LTE network, you're not going to yield that really fast network that you expected just because it's using LTE technology. So you want to make sure that you really check with all of that before you get it going. And then, I don't want to bore you to death with too much network data. And so let me just give you this parting thought. As you're trying to enable your AI programs and get your first win or get to the next level of your digital transformation strategy, remember that the TCO is not simply on the software itself. That is very important. But you really need to pay a lot of attention to the type of connectivity. And will your connectivity, because it's in the IT budget where your AI software is probably in your OT budget, are you making sure that you get the one that is robust enough to run these new latency sensitive apps? Is reducing cost on the network a good thing or a bad thing? by buying a better network, are you improving safety? Will it stay up in any kind of weather? Will the data come through at a higher priority than other things on that network? Because there are many things that don't need to be the higher priority. And if you can successfully answer these questions to the positive, then you're going to drive profitability and you're going to achieve a TCO that has a great return. And so with that, I'm going to wrap this. Hopefully this was some food for thought, and I would be happy to take questions.